Yes, welcome once again to the channel. Yes, so let's start with alpha decay method. Okay, we had seen alpha scattering method. Now we will look at alpha decay method. Alpha decay. According to according to Gamows Gamows theory, which you study in radioactivity. Okay, Gamows theory of alpha decay. Gamows theory of alpha decay. The half life for radioactive decay T half is related to the disintegration constant with barrier lambda s. According to Gamows theory of alpha decay, okay, now you must have studied in your academic years this alpha decay Gamows theory, okay, or you can else search the net and look at it, but I won't go into the details of it over here. Okay, over here I won't go into its detail because this particular part is to be studied superficially as per UPSC requirement. So I will stick to the syllabus instead of going here and there. Okay. So T half will be your, this is according to Gamows theory, ln2 by lambda, and this ln2 value comes out to be your 0.693 divided by what will be there, lambda will be there. Okay. So let this be equation number 1. Now here your lambda is equal to lambda naught e to the power minus gamma. Okay, so lambda naught is your what, decay constant without barrier. Lambda naught is your what, decay constant. All this you have to mug up. Okay, decay constant without barrier. Decay constant without barrier is your lambda naught, and e to the power minus gamma is equal to barrier transmission coefficient. Barrier transmission coefficient. Okay, so these are the things. Now your gamma is equal to what? Now your gamma is equal to, now this part you have to simply mug up. Okay, gamma is equal to your a minus b r naught to the power half. Okay, so substituting this value over there, where substituting this value over here. Okay, so after you substitute that over there, what do you get? You get something of this kind. Therefore lambda is equal to your lambda naught e to the power, in the place of gamma you will substitute this thing. Okay, this is the thing which you get. So this is, suppose, your equation number 2, suppose. Now taking finite size of alpha particle under account, then there's only Bol-Bachchan things are there. Okay, taking the finite size, taking the finite size of the alpha particle under account, it is found by this experiment that the unit nuclear radius is like this: R naught is equal to 1.3 plus 0.1. Okay, here it must be plus minus. Okay, plus minus 0.1 femtometer. So this part you have to simply mug up, copy down this and mug it up. Okay, this particular part, these three slides you have to just copy down as it is and mug it up. This part and this part. Not even numericals are asked based on this. Okay. Now based on the theory which we had learnt in the previous class, which theory? We had learnt one theory. Which theory? We had learnt the alpha particle scattering theory, right? So as we had learnt that theory, so we will solve one numerical based on that theory which we had learnt in the previous lecture. So numerical based on alpha particle scattering method. So numerical based on this. Okay. So problem is there. Question. Estimate. Just a second. Okay. Estimate the order of nuclear radius of lead. Lead has Z is equal to your 82 using the large angle, that is back scattering, of alpha particles of energy 10 million electron volt on a target which is lead. This target is your lead. 2017 PYQ this is. Okay. So what does this say? Estimates the order of nuclear radius of lead. Okay, you have to estimate the order of nuclear radius. Order of nuclear radius means not exact. Okay, and it is rough estimation. So order of nuclear radius you have to determine and it is the metal lead. Pb is its symbol. Its symbol is Pb. Okay, although I haven't written the symbol over here. So Pb is the symbol of lead. So lead Z is equal to 82, means number of protons is 82 in it, and we have to use the large angle back scattering of alpha particles. Large angle back scattering means 180 degree scattering, which we had learnt in the previous class. The 180 degree scattering, that means head-on collision and then retracing its path. Okay, head-on collision and then retracing its path. So large angle back scattering formula, which we had learnt in the previous class, we have to use that. Okay, energy is given 10 million electron volt and target is lead. So what is your formula? First of all, we will draw the figure. Okay, first of all we will draw the figure. Let me erase this. So first of all we will draw the figure. So the figure will look something like this. This is your plus ZE. Okay, now this is your E. So the alpha particle will come like this and will retrace its path. There will be collision over here. Okay, there will be collision over here. Oh, at this point there will be collision. So E is equal to your what? If you haven't watched the previous lecture, then you won't understand this. You won't understand this at all. Okay, 4 pi epsilon naught ZE multiplied by 2E divided by B. What the thing which is the electrostatic potential, that will be equal to your energy, initial kinetic energy, right? Now B, the value of B from here, what will it be? The value of B will be equal to approximately R, which is approximately equal to R. That will come out as your 2ZE square over 4 pi epsilon naught E. It will be like this. Now you know this very well that in this formula, in this particular formula which is there, so let me write that formula once again on the screen so that I am able to see it without returning back to the page. So 4 pi epsilon naught E. Okay, let this be equation number 1. So I will substitute Z is equal to 82 here. Okay, here we have Z is equal to 82. E is equal to what? Charge on an electron or proton, whatever you call it. So 1.6 into 10 to the power minus 19 coulombs. And everything is in SI units. So 1 upon 4 pi epsilon naught is equal to your what? 9 into 10 to the power 9 Newton meter square per coulomb square. Okay, and E is equal to, E, that is the energy, is equal to your 10 million electron. Okay, 10 million electron volt. So that is equal to your 10 into 10 to the power 6 electron volt. Means what is electron volt? It is 1.6 into 10 to the power minus 19 joule. Okay, electron volt is 1.6 into 10 to the power minus 19 joule. So all these values, when you will substitute, this is your homework. This is 2, by the way. Okay, so after you substitute these values in 1, you will get the value of B. After substitution, you will get the value of B by this equation number 1. And after you get the value of B, you can write that B, okay, let me write properly. The value of B that is the distance of closest approach, the value of b, that is the distance of closest approach, is approximately the nuclear radius. Therefore, r is equal to whatever value approximately. Don't forget to put the sign of approximately. Okay, you will always have to put the sign of approximately over here. Then whatever value you get from the previous this formula, whatever value you get from this formula, just simply write down that value. Okay, so I haven't calculated that. Now we will learn about mass defect, but we will learn about that in the next class. If you haven't watched the previous videos, then please do watch them by clicking the link in the description and going back into the playlist, and starting from the very first blue colored thumbnail, you will be able to see the nuclear and particle physics. The first blue thumbnail shows the nuclear and particle physics starting. Okay, before that it was quantum mechanics. So in this way. So thank